Good morning, Collegiate Academy. This is Mr. Stewart, who serves as your 7th and 8th grade science teacher. And this week, we'll be going into electromagnetic tides and wavelengths, which ties into the lesson Images from Space. Before we get into our video, I want to ensure that you remember our norms, and that is to always mute your mic, stay on task, make sure that you have a notebook out so that you can write down information that'll be helpful with your assignments. Ashe? Ashe. Now I'm going to share my screen and we will go right into the lesson. All right. Invictus. Out of the night that covers me, black as the pit from pole to pole. I thank whatever gods may be for my unconquerable soul. In the fell clutch of circumstance, I have not winced nor cried aloud. Under the bludgeonings of chance, my head is bloody, but unbowed. Beyond this place of wrath and tears looms but the horror of the shades, and yet the menace of the years finds me and shall find me unafraid. It matters not how straight the gate, how charged with punishment the scroll. I am the master of my fate, I am the captain of my soul. Invictus. We already went over our norms, so we can go right into our lesson. Images of Space, Week 5, which starts on 5/11/2020. The learning objective is I can write 5 to 7 sentences on electromagnetic spectrums along with its parts, define wavelengths, and compare images from space based on the information provided from my graphic organizer and my PowerPoint slides. Ashe? Ashe. The standard is PS4.B, electromagnetic radiation and wavelengths. Collecting information from space and analyze how different wavelengths of electromagnetic spectrum provide different information. When light shines on an object, it is reflected, absorbed, or transmitted through the object, depending on the object's material and the frequency, color of the light. Ashe? Ashe. Now let's jump right into it. Electromagnetic spectrum. The electromagnetic spectrum, also known as EM spectrum, is also the frequencies or wavelengths of electromagnetic radiation, including radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. So in this case, when it comes to wavelengths, you can gather wavelengths. Like, so for instance, if you go on your car and you press the power button and you press play for Power 99, or you want to play your iPad, that is a form of a wavelength coming through energy. Ashe? Ashe. Frequently and wavelengths are inversely proportional. Furthermore, the energy of EM waves increases as the wavelengths decreases. So what happens when the energy of EM waves increase? The wavelengths decrease. Ashe? Ashe. Observing and detecting electromagnetic radiation. Telescopes are used to concentrate radiation. So what are used to concentrate radiation? Telescopes. Different types of telescopes and detectors are used for different ranges of radiation. So now we know that we have different ranges of radiation. Telescopes in space collect what? Electromagnetic radiation that does not reach Earth's surface. So the telescopes in space collect electromagnetic radiation that does not reach Earth's surface. Ashe? Ashe. Electromagnetic radiation that does not reach Earth's surface. Ashe? Ashe. Using images from space. Images of Earth provide information about weather, temperature, land usage, and changes over time. Images are used to study the sun, other objects in the solar system, nebulae, galaxies, and positions of objects in space. Ashe? Images of planets and objects in the solar system show atmosphere, clouds, auroras, and many details of solid surfaces. So we know that images in space are very, very versatile. Images of Earth provide information about weather. Images are used to also study the sun. Then images of planets and objects in the solar system shows the atmosphere, clouds, aurora, and many, many more details of solid surfaces. Ashe? Ashe. I want you guys to be aware of what images do for later on a quiz or a test. Ashe? Ashe. Now, I'm going to show you an experiment of Newton's light. He uses a glass which allows the sunlight to shine through it in order to depict a color that bounces off or reflects the surface. Ashe? So I want you guys to take a look at this experiment because I think it's pretty cool. Stop sharing my screen for a second. All right. Now I'm going to share it again with the video. And we're here. Watch your eyes. Amazing. Shay, what you think about that video? I have a question in regards to that. I'm going to share my screen again. All right, now for your exit ticket, you are to write it down to help you with your assignments. Based on the video provided, what did you learn from watching the Newton's light spectrum experiment? Use some of the information that was provided. What are some things that you saw that was very, very intriguing to you? What were the coordinates between the split in the light? What happened between the correlation of that and how it caused color to reflect off one another? You are to write 3 sentences, including it with your first assignment, Ashe. So the first assignment is due that Monday. Things to remember. Please use this video to complete the assignments on your checklist. All questions are in order. Ashe? Ashe. Now, with that being said, have a great day on purpose. Have a great week on purpose. Remember to always, always be prosperous in your virtual journey. Continue to shine. Continue to work hard. Mr. Stewart loves you. Have a great day. Have a blessed week. Be safe.